In today's lesson, we're talking about FMOD's playback states feature. We'll be experimenting with them and learning about each of its associated states. And we'll also be looking at how we can interact with an event instance that was created within a script attached to one game object from another. So a playback state is a tool from FMOD's API. We can use it to find out what the audio from one of our event instance variables is doing. For example, we can check if it is playing, starting, stopping, has stopped, or has hit a sustain point. These 5 examples are returned to us from our playback variable that we can create in the form of states. The 5 main states are called playing, starting, stopping, stopped, and sustaining respectively. So we're going to look at how we can use them with a playback state variable. In order to see these states in action, we'll be editing our code in our music player script. And we're also going to look at how we can use them with our bus controller script as well. So we're going to start by finding our music player script in our FMOD folder in our assets. We're going to open it up. We're then going to create a new private variable. So we're going to write private and then write fmod.studio.playback_state. And we're going to call it music state. So this is a playback state variable, and we're going to use this alongside our music event variable to tell us when the event assigned to it is playing. Now notice how playback state is highlighted yellow. Now back in our event instance lesson, I mentioned how parts of our code highlighted yellow means that that part is an enum or an enumerator. Well, just like our stop mode command, playback state is an enum. Now an enum is a collection of user-created integer constants. These constants can be called whenever you like and are basically a way of creating a set of possible outcomes or options for you to use. Now if we wanted to create our own, we'd start by writing the keyword enum, declaring that we are creating one, and then give it a name starting with a capital letter. So for example, if we wanted to create one to determine what type of audio we were playing, for example, we might call it audio type. We'd then give it a body, and inside the body we could declare our constants. So for types of audio, our constants might be called music, sound, dialogue, and ambience. So if we wanted to access one of these constants, we'd write the name of the enum, followed by the dot operator and the constant we were after. So for example, in the start function, I could call one to my console tab by writing debug.log, and then writing audio type dot sound. Now note that audio type is not actually a variable, but we can store it inside one. To do this, we'd write the name of the enum itself, which is audio type, followed by a name such as audio check. So this is essentially what we are doing with the playback state. If we hit Control and click on it to open up the script it was declared in, we can see the enum along with all of its constants. If we want to, we can even hit Control F, search for stop_mode, and by pressing the arrow a couple of times, we can actually find where stop mode was declared. So when we reference this enum, we're essentially creating a variable of it, almost like an instance of it, in the same way that we do with our events. We can then use this alongside an event instance variable to check to see what the event inside it is doing. If you'd like to learn more about how you can use enums in C#, I'll have more resources at the bottom of this lesson for you to access. So let's quickly delete this sort of demonstration of an enum here, and also in our start function as well, so we can talk more about the playback state specifically. So let's say that we want to check what our music event is doing every frame. We first need to come down to the update function, then reference our variable music inst. Then we need to use a command called getPlaybackState, which looks like this. Now it's by using this command that we can tell our playback state to check for our music event. So inside the brackets, we need to write the keyword out, followed by the name of our playback state variable, which in our case was music state. Finally, all we need to do is make some space and write a debug.log command with the name of our playback state. So it was music state. Let's then test to see what this will look like in our console tab now by saving our script and quickly jumping into Unity to run our game. So as we can see, whilst the music is playing, our playback state is set to playing. But if we run over to the portal, which we know will tell our music to stop playing, we see it switch to stopping. Once it has stopped, we get the word stopped. And then once it starts playing again, we briefly get the word starting, followed by playing. Now, it's important to note that the getPlaybackState command will only check our event state on the frame it is called on, even if the state changes during another. And to demonstrate what this means, I'm going to cut mine from the update function and I'm going to paste it into the start function, so that it will only be called on the first frame. So if I then save my script and jump back into Unity to play my game and check the state of my event, we can see that whilst we are checking the state every frame, the state has only been set once at the start of our game, meaning that until we call the getPlaybackState command again, our music state variable will remain as starting. So now it's time to use our playback states a little bit more practically. Here we are back in our audio settings menu we set up in the last lesson, and if we adjust the level of the master volume slider, we can clearly hear the change in levels because the game music is being played in the background. By adjusting the music volume slider, we can also hear the change in level of the music as we adjust the music slider up and down because, again, the music is playing. However, there's nothing to tell us that we're lowering or increasing the levels of our sound effects as we move the slider. Well, what we can do is play a sound effect whenever the slider is adjusted by the player for reference, and we can use playback states to help us with this. First, we need to create an event which will play when the player adjusts the slider. Now, since this event will only be played when the player is interacting with UI elements of the game, we will create a new folder called UI for it, as well as any other sounds we might wish to play whilst the player interacts with the menus of the game. Now, you can create any kind of event you like, but it must be a 2D event, and I'd recommend creating one that won't sound too repetitive if played over and over again. For example, I've created one in my UI folder called Level Test, and when played, it will trigger a multi-instrument to play one of 13 jumping sounds. Now, if we jump over to our mixer, you're also going to want to make sure that the event is being sent to the sound effects bus. And once you've done all that, hit Ctrl S to save your project and hit F7 to build your bank. So here we are back in the F_bus control script we created in the last lesson. In that lesson, we created our function that is called whenever the player moves one of the UI sliders. So it's this function that we'll be using to trigger our audio event to play. First, we want to set up a system that will create an event instance for us, play the event, destroy it when finished with, but only for when the sound effects slider is interacted with. Now, this is important because in the last two lessons, we actually attached this script to all three of our slider objects, meaning everything we do in this script will happen 3 times, including creating an event instance. Now, obviously, we only want one instance of the event to play for our sound effects slider, and we don't want to create any extra instances unnecessarily, so we'll have to check which bus our slider is controlling. So let's start how we usually do. Inside our class, we're going to create an event instance. We'll give it a name such as level test. Now remember, in the first lesson of this module, we added the FMOD.studio namespace and the FMOD Unity namespace, meaning that we don't have to declare them before we declare an event instance. So now, as the 3 slider components are activated, 3 empty event instance variables will be declared, all of which are called level test. Now, normally when creating an event instance of an event to play, we'd usually assign an event path to the variable inside one of our functions. However, this time we want to first check to see if the component of this script is being used for the sound effects bus in FMOD specifically. Well, what we can do is inside of our start function, we can create an if statement. And inside the if statement, we can check to see if the bus path variable we created is ever set to sound effects. So we'll write bus path, add a comparator, and write sound effects as a string, and if it is, we will play our event. Now, it's worth noting that there are multiple ways we could set this up instead of checking for the string inside of the bus path variable. Another way would be to create a public boolean variable and check in our if statement if it were ever set to true in Unity's inspector tab. We can then set the components using this script that are attached to any sliders we want to play this event to true, whilst leaving the others false. But seeing as we only have one slider to check for, however, we might as well check for it directly with this method. So next, inside of our if statement, if it's true, we'll set our event path to this instance. So let's write level test equals runtime manager dot create instance, and inside the parameter brackets, we're going to write out the event path for it, remembering not to include the FMOD Unity namespace as it's already been referenced. So now we have 3 event instances, all called level test, 2 of which are still empty, whilst the third now has an instance to our level test event in FMOD. Now, seeing as we only need 1 of these, we can now destroy the other 2 that are still empty. And we'll be doing this by using the else statement underneath our if statement. So we obviously know that the else statement will only run if the previous if statement condition is not met. And in our case, if the bus path string is not sound effects, then whatever we put into the else statement will be run. In other words, this statement will run if the bus pass is either equal to our remaining music or master buses, the 2 buses we don't need event instances for. So it's in here that we can destroy our 2 remaining empty event instance variables. So let's write the name of our event instance variable, followed by the .release command to destroy them. And we now only have 1 event instance to our level test event, specifically for our sound effects bus. Perfect. Now you might think that from here, we just want to tell this event to play whenever the slider is changed by our player, by adding the start command into our volume level function. Well, this is actually going to give us a few problems that playback states can actually fix for us. So to demonstrate those problems, I'm going to quickly save my script and show you what might happen if we left our script like this in our game. So now if our player is in the middle of their game and decides to turn down their sound effects, this is what they'll hear. So what's happening here is on every frame that the slider changes value, the event instance is being told to play. But because there are so many frames where the slider changes value, and we only have 1 instance of the event to play, the event is forced to start from the beginning on every frame the value is changed, creating a very messy sound. Now this is the issue that our playback states can fix. So let's start by removing the start command, and at the top of the script we're going to write a playback state variable, and we're going to call it PB for short. Then inside of our volume level function, we're going to create another if statement and do the same thing we did in the start function. We're going to check that the player is actually interacting with the sound effects bus only. Then we're going to want to get the state that our event is currently in when this function is called and output it to our playback state. So let's write level test dot get playback state, and inside its brackets write out PB. And now we can check the state our event is in whenever our sound effects slider is changed by the player. So now we're going to write another if statement inside of our first one, and this time we want to check using our state to see if the event is not already playing, and if it's not playing, we'll then tell it to start. So inside the condition brackets, we'll first write our playback state variable, which is PB. Then we'll write an exclamation mark and an equal sign, which we know is a comparator that checks to see if 2 conditions are not the same, followed by the state we want to check for. Now we want to specifically check to see if the event is not playing. So we will write playback state dot playing. Remember it again, if we did not have the namespaces at the top of the script, we would have to write in the if statement fmod.studio.playbackstate.playing. Then if this condition is met, we will tell it to start. Now the event will only play if it is not already playing, preventing us from hearing it awkwardly stutter. Cool, so let's save our script and check it out in Unity. So now, whilst our game is playing, if we move our sound effects volume slider, we can only hear the event play once. The event isn't told to start again until it is finished. We also move one of our other sliders. The event doesn't play, meaning that it only plays for the sound effects slider. Last thing for us to do is to destroy the remaining instance so that it doesn't carry over between scenes. So what we're going to do is come down to the bottom of our script. We're going to create an onDestroy function. Let's again check that we are interacting with the event instance we're using for the sound effects slider. And once we've made that check, we're going to write level test dot release and then save our script. And that's all the basics you need to know in order to use playback states. And we've learned about how we can create enums in C# and what they do, how to use them and how FMOD utilizes them for its events. We've also learned how we can use the get playback state command alongside an event instance variable and a playback state variable as well. So now you've done all that, maybe try setting up some of your own playback states with some other events that we've already told to play in our game so far and see what happens. And as always, thank you for taking part in this lesson, and I will see you in the next one.